Hello, ladies and gentlemen. Today we are at the Linux conference of year 2019. My name is Vasily Tolstoy, and together in front of me is Mr. Michael Kerrisk.
Hello.
Mr. Kerrisk is the maintainer of the man pages of Linux and the author of the classical book on Linux API. And today we're going to talk about the matters related to that. So you're 20 years in the man pages.
Nearly.
Great. So you're the guys who knows everything about that.
I wouldn't say that, but I know a lot.
Some of the guys, probably from the younger generation, who think that the system just appears, will say, oh, there's the guy who's responsible for the man pages. So if I can't find anything there, so you are the one who hadn't put it there. I hope it doesn't work this way. So what are you actually doing in the position?
I will take bug reports from people and perhaps respond to them by writing documentation. If I'm luckier still, I will get patches from people with changes to the documentation, and I will review those and merge them into the manual pages. If I'm even luckier, and this is actually quite rare, I'll get a patch from some person, a review from some other person, so I don't even have to do the reviewing myself, and then I merge. But that's unfortunately rather rare. Aside from that, I do actually write a lot of the manual pages myself.
So am I right that the man pages of Linux is not just the documentation for every single piece written absolutely separately, but it's a system?
I'm not sure what you mean by a system. So perhaps...
I mean, it's all interconnected, and when the changes in man pages for, say, ls tool has something to do with changes in some other tool.
So the manual pages that I maintain are really just about the system calls and the library functions, but obviously there are tools, user space tools, that are layered on top of these. And so there is interconnection, of course. So there are projects like Util Linux, which provides a lot of command line tools that people use every day. And there's quite a close relationship between some of the tools in that project and the system calls whose documentation I maintain. But you know, that project has its own manual pages, which are maintained by them.
Great. You're giving the talk of this conference. Can you tell us what it was about?
Very generally, it's about the long-term health of the Linux API, because we have a steadily evolving programming interface that the kernel presents to user space programs. And we started off with UNIX at the beginning, but then since 1991 Linux has been defining its own API, and this evolves over time, and sometimes it evolves in surprising and strange ways, where you get different parts of the interface that are interacting with each other in ways that people perhaps never individually thought of, but the interactions end up, for some interfaces, creating quite strange results. And so my talk was about one particular system call that was added to the Linux kernel about 22 years ago, and just to explore how that interface's behavior has changed over time because of changes elsewhere in the kernel, but also some surprising behaviors of the interface that people never even considered at the start. They were there at the start, but people never considered these behaviors, and so when they eventually discovered the behaviors, it was surprising.
So this API call was added quite long ago.
Quite long ago.
And you can correct me that if I remember correctly, the total amount of system calls in Linux, I mean the classical ones, which are like interrupt in the kernel and so on, it's about 300.
It's more than that by now. We're somewhere in the vicinity of about 450 by now.
Even more than 400.
And lately we've been adding system calls at quite a fast rate. So
it was my next question, actually.
Yes.
So that we really do expand the API of the Linux in the classical sense, even today.
Yes.
And in what areas they got added?
We've currently had some new system calls relating to process lifecycle that have been added. These have been added by Christian Brauner, who I think was at a previous iteration of this conference.
I know him, actually.
Yes. So these system calls, one of the long-standing problems with Unix, not just Linux, is if a parent process wants to monitor a child process, the way of doing that was using a process ID. But process IDs can be recycled, and so a parent can't necessarily be sure that the PID that it's using really refers to the child that it created, because that child might have terminated, the PID might have been recycled. And so if the parent used that PID in a signal system call, for example, to send a signal to the child in the kill system call, then it might actually be sending a signal to a different process than it thought it was sending it to. So what Christian has added is some interfaces, some system calls. I think by now he's recently added 3 system calls, which essentially are about providing a new way of monitoring a process. Instead of using a PID, have a file descriptor that refers to the process. And that file descriptor only remains valid as long as the process that it was originally referring to remains in existence. If the process terminates, then even if the process terminates and its PID is recycled, the file descriptor now gives an invalid message saying if you try and use it, this process actually no longer exists. So we don't have the recycling problem. So there's been about 3 system calls added there. 2 or 3 kernel releases back, we had 5 or 6 system calls to do with a new mount API that's being added to the kernel. So actually in this year alone, we've probably had between at least 10 new system calls, I would say. And
fantastic.
We steadily add new system calls.
It changed the picture for me, at least. So, what do you think? Is this tendency going to be the same in the future years? Like adding, expanding, and expanding the API of the kernel?
I think so. A lot of these things come out for me personally. Like a lot of these things that they will emerge, I'll be unaware of them, so they're slightly surprising to me. That's just because I don't follow everything. But it's been the pattern for as long as I've been observing the kernel, and especially it's quite bursty. Like sometimes there'll be no system calls over just one or two over several kernel releases, but then suddenly there'll be a whole bunch. So we had this kernel release a wee while back with there were 5 system calls, I think it was, or maybe it was 6. But we had the same thing happen, I think it was in kernel, it was a 4 series kernel, where again we had in one kernel 4 new system calls in a single kernel release. So it is somewhat bursty, but over the long term, yes, we keep steadily adding more system calls.
Okay. Does it mean that the Linux is going further and further from other, kind of Unixes we have around?
Yes, because...
So they're not copied to the other stuff, it's the Linux-specific things? Like FreeBSD as a usual.
So, I mean, the thing is, most of the commercial Unixes, to a greater or lesser extent, have gone away. They cease to be actively developed. So that only leaves really the free implementations after that. And the thing about Linux, there's so many developers working on Linux that the developer mindshare just means there's more stuff getting added. And the BSDs, FreeBSD is the most notable, really. They are not keeping up.
Okay, it's an interesting thing. I'm still digesting it. Actually, I have attended your talk. It was a very interesting one. If you haven't got a chance, download it and look at it when it would be available. Then you have told there, which I knew before, that absolutely not all of the system calls get the nice wrappers in libc.
Sometimes it takes a while before a wrapper function lands in glibc. Sometimes wrapper functions never land.
So can you think, just from top of your head, of how many of those 450 calls has no wrapper in libc and need to be called directly?
I would say roughly it'd be something between 20 and 40.
Oh, not so much actually.
The majority have wrapper functions. Probably, when I think about it, it's certainly more than 20. It's probably more in the range 30 to 40. Part of the reason that and that's quite a lot, I consider, that don't have wrapper functions. And part of the reason for this is there was a certain philosophical debate going along in the GNU C library community about, should we be exposing these Linux-specific features as part of our library? Because in some sense we have to support this. And so for a long time there was a period of several years where new system calls were being added, but they were not getting wrapper functions in the C library, in glibc. But in the last sort of two years or so, there's been a philosophical change again, and now they are steadily catching up with adding wrappers. So there was, from my point of view, interestingly, a certain system call that for more than 15 years didn't have a wrapper function. 10 years ago I already filed a bug report saying, I think we should have this wrapper function. After 10 years we got it.
just in years.
Yeah.
The good things need to be mature before actually appear to the general public. The man pages and the traditional Linux API, they come together, and we actually expect that the kernel API call would sooner or later get the online documentation, the same Linux. It very nicely comes together. Everybody is happy about that. But in the last, I can say, couple of years, and like dozens of years, we're getting other interfaces to the kernel, like the file system, like sysproc, whatever, and the different kind of fancy sockets. And Netlink is a typical example.
Yes.
And those are sorry, those are also the kernel API.
Yes.
But we are not, at least I do not expect they have to be the same level of documentation as the usual system calls. What do you think about that?
I think
I'd like to, but
I think they should be. But you're right in observation. They often are not. The proc file system is moderately well documented. There's certainly many gaps. But for example, for the sysfs file system, until 3-4 years ago, there was no manual page. Now there is a manual page, but it has many gaps. Things like Netlink are even worse.
Yeah,
there's very little documentation about Netlink, which is pretty unfortunate from my point of view. And while I write many manual pages for many system calls, I can't keep up with everything.
Naturally.
I'm very much dependent on people providing documentation that could be included in the manual pages. And occasionally I get very lucky. I have some people who provide, sometimes some very good manual pages, but then there are, as you notice, other areas where there is very little documentation, and I have not been lucky.
Okay. And what do you think? How should the documentation of those things progress, be implemented actually? As expanding the set of manual pages, the man pages, or there should be some other standard documentation source for the socket interfaces, something like that.
There's two places where these interfaces tend to get documented. One is manual pages, but the other is the kernel documentation tree. And so you'll find some information in there about the sys file system, for instance. You'll find a lot of information in there about the proc file system. I'm not quite sure of the status of netlink. There is, I think, some documentation in there. The problem with, to me, about the kernel documentation, yes, it can be useful, but it's a bit more hidden. You know, people need to install the kernel tree, and they need to sort of discover where to look to find the particular documentation.
Yeah, whereas being application programmer, it's quite a counterintuitive thing.
Yes.
I need to go to this system documentation place where I want to just learn how to use it.
Yeah, and whereas the manual pages tend to be much more easily accessible. They're just installed on your system, typically. But also they tend to be much more integrated or coherent with one another, where there'll be cross-referencing across manual pages. At least that's one of the things I strive for. Whereas the stuff that is in the kernel documentation tree, these tend to be sort of smaller, sort of monolithic pieces that don't necessarily provide a wider context.
Yeah, they do. And they are this way. So I can.
So I think the answer to your question is, I think that manual pages is where this information should be.
Okay, I would support it with both my hands, because I have my own share of pains in this area. And as I have mentioned before, you're the author of the classic book. I've seen it on the tables of my colleagues. I have one of my own. And to present you a practical example of the thing. Let me this one. The great monolith of a polygraphical excellence with a green insides. 1,400 pages, ladies and gentlemen.
1,500.
400 something.
1,552.
This one ends off 500.
Oh yes, this is the front matter. The front matter has Roman numbering. There's about 50 pages of front matter.
The professional. In comparatively, but fine print. And it's a really fantastic source of information. I was absolutely stunned when I found it. I was under the impression there's things like that doesn't exist. And it covers a lot, actually. It's not just a collection of man pages. I must say to the ones who are still thinking, should I pay what does it cost, $50?
Depends where you buy it.
It's not much, not 100. It's cheaper.
The cover price is 100, but usually when you buy it from online retailers, it's cheaper than that.
It's cheaper. I got it cheaper than 100.
Yes.
But still, there's a Russian translation, by the way. And there are a lot of translations, but for us, it's more important this Russian one. The book covers not just the API itself. It's not a collection of man pages, and not the collection of the kernel API per se.
No.
It also talks a lot about how to do the actual programming, how the threads run, how the process schedules, what those virtual file system to inspect the kernel, and other stuff. There's a lot of things covered. Unfortunately, it doesn't have the section about socket interfaces, which are my favorite.
It does have some information. Do you mean netlink sockets?
Yeah.
Yes. No, it doesn't.
Have you any plans of the future edition? Because I understand that we have only one edition of that.
Yes.
And it's 2010.
2010, yes.
So, keeping in mind what you told about the rate of the adding in new system calls, it's a bit outdated in a sense.
There is a lot of new stuff since then, since 2010.
Can we expect?
It is on my mind.
Please.
It is on my mind. But I actually have a couple of other book ideas that I'm interested in exploring as well. But it's on my mind that to do a revision of this book.
I will anticipate it trembling.
When I finished the first edition, I needed a few years of recovery. Because it was quite an effort.
And it was very clear. And my favorite part, because it was consulting it specifically for that, it was the EPOL part. Because I have not to flatter myself, not master it but got some grip of the EPOL cycles, taught it just part-time to the students, like a fine example how we can do the interesting thing without going multi-thread and so on. And thinking of this chapter, I came to the funny thing, to a funny idea. Do you feel that you are actually not just collecting the best practices and, well, telling the guys how the system is constructed, but also influencing the style, how the people are coding? Because you somehow explain how they should be done. And the guys do.
I really don't know. I suppose it is possible that I am, but in a way, it's quite hard for me to perceive the impact that my book has on the programming community. In a way, what I'm trying to say there is, I know that many people like the book, but for me, I can't see the book in a naive way. By comparison, for example, I remember the very first time I came across Richard Stevens' very first book.
Yeah.
And I had been programming...
Those about the interprocess communication and IP and stuff.
Yes, this was his first edition of his Unix network programming book, which was 1990. And
it's a great book still, by the way.
It's been revised since, but the point was that when that book came out in 1990, there was nothing comparable. And
it still isn't, by the way. It's my personal opinion.
Yes, for network programming, I agree. At that stage, I'd been programming on Unix systems for about 3 years. I had learned from another book by Mark Roshkin, which was quite good, but there were many things that it didn't cover. And so a lot of stuff that I'd learned subsequently has been self-taught. And then I found this book, which crystallized so much of the knowledge that I had sort of struggled to obtain on my own. And so immediately I could see it was a great book, and I absolutely had to buy it on the spot. But I can't, I could see that book was a very good book, and I know that some people say that my book is a good book, but I can't see it in the same way that, for instance, I saw Richard Stevens' book so many years ago, because I don't come to it fresh.
We should do some tests on real people with you, like peeking through the hole and see this book, read it through. Wow! Look! They jump.
One of the very nicest pieces of feedback I had for the book, when you say it like that, was I was sitting at a table of a small conference some years ago, and I heard one free BSD developer, or maybe it was OpenBSD, a BSD developer talking to another BSD developer, recommending this book, without knowing that actually the author of the book was sitting right next to him.
It was so nice.
I thought that was one of the nicest pieces of praise.
I can imagine that. It was extremely nice. So, to put this historical moment on video, I would like you to sign it for me. I have the font and pen. I have everything prepared. Please do that. I'll put it in the crystal box.
I'm very unused to writing with a fountain pen these days.
Oh, they are nice. They glide nicely, so you can just don't press too much into.
Yes, I understand. I won't close it yet.
Yeah, sure, it needs to get dry. So now this thing costs much more than 100. You see, behold my business skills. Just joking, I will never sell it. It will be sit on my desk for eternity. So, thank you very much
You're very
for
welcome.
this interview. I would like to talk to you much more. Just want to how say get this to the end, so our viewers could how say have their time organized. And if you guys want to get a chance to catch people like Mike Kerrisk, there's no like Mike Kerrisk, but well, somebody comparable to him. You can visit the Linux conference, and we try to bring some interesting speakers to you. Thank you very much.
You're very welcome. Thank you.